in section scalar triple product is defined in the same manner like if the product of three vectors gives a scalar quantity, that is called scalar triple product. For three vectors A, B, and C, you can write here A dot B cross C. Some students ask the question why we write here the cross, not dot. If we put a dot here, then B dot C gives a scalar quantity that is not feasible with the vector A. That is, we cannot multiply scalar quantity with a vector. Rather than cross, if we put here cross, then B cross C will give a vector quantity that is feasible with the vector A to multiply. Otherwise, multiplication with the vector or scalar is not possible. Now, these three vectors in the component form can be written as AXI, AYJ, ZK, similarly B and C. First of all, we will multiply B and C by using determinant method. Again, first row, first column, then plus first row, second column, and first row, third column. We will get these three terms. And finally multiply with the vector A. That is AX with X component, AY with the Y component, and AZ with the Z component. I dot I will equal to 1, J dot J will equal to 1, and K dot K will equal to 1. So these three terms are obtained in the result of scalar triple product. This can also be obtained by a simple determinant method. We write like AX, AY, AZ, BX, BY, BZ, and we will get the same result like this one here. Both process will give the same results. These are some important features of the scalar triple product. For example, first one is called cyclic order, because scalar product is a commutative. So if we change the order of dot with A, with B and C, no change occur in the resultant. And these three quantities gives a volume that is also called pivot. Here is shown pivot. Pivot is basically simply a cube with the three sides, one side along x-axis, other side along y-axis, and third side along z-axis. Second is the cross product order in the brackets, this one. This order cannot be changed because cross product is a non-commutative. If we change product of bracket terms, that is C cross B, then this will equal to the minus volume. Remember that volume can not be negative, but here negative mean only the direction of the resultant. Like if the direction is upward, then in the other case, this direction will be the downward. And nothing change will occur in the magnitude. Magnitude of both these first and third features will be same. Similarly, for coplanar vectors. Coplanar vectors, I will try to explain here about something. That this is a plane. These are known as coplanar vectors. If the vectors lie in the same plane, they are known as coplanar vector. The resultant of coplanar vector is the 0, because these vectors are also known as equal or parallel vectors. If we solve this one, this will give the sign 0, and sign 0 is equal to 0, and whole term will be equal to the 0. Fifth is the if any two of three vectors are parallel. For example, either B or C. Parallel means theta 0. Sin 0 is 0. Again, resultant will be equal to the 0. And the last one is the identical vectors, two identical vectors. One with dot, another with the cross. This will also give a 0 resultant. You can solve here. First column AYCZ minus AZCY. Again minus AYAXCZ minus CXAZ. These all terms will be the cancel with each other, and you will get a null vectors. Oh, sorry, a zero magnitude. Again, if the two rows or two columns of determinants are same, this is the fundamental rule of mathematics in the determinant methods. If two either rows or columns are same, then this will give the zero resultant. Here you can also see two rows are same, first two rows like this. That's why resultant is the zero. Hopefully you have understand all these multiplication or scalar triple product and direction cosine and rectangular components. You can give us feedback at our website. Thank you very much. Allah Hafiz.